Everyone see my screen?
You can see.
Yes.
All right. So I'm not going to be able to see the message in the chat. So if you have any questions or anything, just say something, open your mic, say something to me, and I'll respond. So to just kick things off, using tutorial 1, I want you to just tell me which question you want me to work.
Just start with number 2.
On tutorial 1, question 2.
Yes, yes.
All right, no problem. Let's see what tutorial 2 is saying. Tutorial 1, sorry. All right, so it says the surface area of a sphere. Open up the tutorial on your phone or something else. Yeah, so it says the surface area of a sphere of radius r is given by a equal this beard my handwriting not really used to writing these, so pi r squared, and let's tell you that r equal, if it's too thin, just let me know please, or too big, whatever the case is. Plus or minus 0.5. All right, I want you to calculate the absolute error in A. All right, so what we know about absolute error? Or what the formula for absolute error? Anybody just respond.
That's a measured minus the expected divided by the expected. All right.
What was the question?
What do you know about absolute error?
So the expect is the measured value minus the expected value divided by the expected.
All right, so there are three formulas that we use for errors. There are three main rules that we use for errors. We're just gonna write them down on the screen. You should have them in your notes already, right? But the first one is that when quantities are added, the errors are added, right? It's what we just putting that out there. The second one is that when we have them being multiplied or divided, we do the sum of the fractional errors. And the third one, which is the one that is important to us, is this. If we have y equal a to n, then the error is equal to the power times the error over the actual value. Let me keep this consistent. All right. Now, we know that the absolute error in A would be let me just record the whole thing. 2 times the 0.5 that they gave you divided by actual value that they gave you, which would be 15. This would be your delta A over A.
And so that's 2.
Yeah, sorry, I'm trying to write that to a bit better. So your power, if you know R squared here, so right? So the is your power. The equation in this case is your A and the N is a 2. Tell me if everybody's seen that. Anybody have any doubts with that?
So that's how you find it when you're dealing with powers. So you're going to deal with
Yeah,
power.
the formula you use. If you have any value equal something to the power, the error that you're going to have is the power times the error divided by the actual value. So using the same 4 pi squared, your 2 is your power, which is n. So that comes to the front. They gave us the error here, 0.5, and they gave us the actual value, 15.
No.
Everybody seeing that?
Sorry about that.
Is there anybody that have any doubts with that?
No, first seeing this one. I'm not used to first seeing this one. Understand the question as they go along. So we'll just work it out.
Let's see what the other person is asking. No, more you notice something now. The delta A part, this is 2 times 0.5. And the A part is 15. So the delta A in itself is equal to just 2 times 0.5. So this thing right here gives you your fractional error. This right here gives you your absolute error.
Could you repeat that, please, about the fractional error?
This right here gives you your fractional error. This here gives you your the top one gives you your fractional error, the delta A over A. This gives you your absolute error. All right.
Excuse me, sir. Why don't you transpose the A in the denominator?
To find delta A,
Yes.
I know that, for example, well, not for example, I know that if I have delta A over A, then I know that whatever is on the top is equal to whatever is on top on the other side. You understand?
Yes, sir.
Come on. For your greatest percentage error now, what we're doing is using the fractional error, which you have here already, whenever we actually calculate it, but we have it here 2 times 0.5 over 15, and we'll just multiply that by 100. Anybody can work that out and tell me what they get, please. Just put the 2 times 0.5 divided by 15, multiply that by 100.
I got 6.66. 6.66.
Anybody else got that?
Same thing we get.
Go again, repeat that one.
6 and
You're
2.
doing a fractional error times 100. That's how you get your percentage error.
Antonio, sorry. You think you can zoom out, please? All right.
The fractional error is 0.066. The percentage error is 6.66.
Antonio,
Yeah, tell me.
which one say was the absolute and the greatest error thing we were mentioning?
This is your fractional. Where you have this fraction, the delta over A, that's the fractional error.
Okay. And absolute is the last one you have down there, sir?
The absolute error is this, and somebody had actually pointed it out. This should actually be times A. You're right. For your absolute error. So how you would calculate that, you'd simply say A equals 4 times pi times 15, keeping everything in mm, so we're gonna get mm squared. Which would give you They've actually given you 900.
Shouldn't it be like the fractional error times the A?
The fractional error would be this.
Yeah, so shouldn't that 2 times 0.5 be over 15 as well?
Yeah. Would be this times your A. I'm working out your area, which would be 900 pi. In decimal, that would be 2027. Please bear the bad handwriting. 0.43.
Yes, saying that
To get
absolute
your,
error is
the
2 times
absolute
0.
error is a delta A, and your fractional error is a delta A over A.
So you're sure 4 pi times 15 give 900 pi?
4 times 5 times 15 squared. 900
Oh,
pi.
15
Yeah.
squared. Oh, correct. All right, sir.
Yeah, man. That's the area up here. So. And so you have 2 times 0.5 over 15 times 900 pi. I'd recommend that if you have a calculator that can give you the pi symbol, I'd recommend that you not use the decimal version and use the actual pi in your calculator so that you keep your answer as exact as possible. We want to get for the absolute error now. You're doing
189.4.
So we'll get 188.49, but that's close to the left. You're doing 2 times 0.5 divided by 15 times 900 pi. As I said, this is keeping the units consistent. You're doing everything in mm. You could also convert the area here to meters squared, convert the radius, sorry, to meters squared, and calculate your area using that. You have any questions, anybody?
So you know that equal 900 pi.
All right, 15 squared gives me what? 225, right? Right?
Yeah, man.
Yeah, right.
You put that in your calculator to get 225, and then you multiply by 4. What you get? 225 times 4.
Yeah, man, I get
900.
900.
Oh, okay.
So what you need to do is that you have to use up the calculator. You're in university now, and you're going to work with you get a lot of decimals, and especially when you're doing, well, probably for the same for all disciplines, but your decimal place matter, especially when you're multiplying mega, kilo, giga. The decimals will affect your answer. So you, as your teacher in high school, probably say, or community college, don't round off too soon. So if your calculator can actually use a pi symbol, then use that. All right. What the next wait, what them ask you here? So them ask you for the volume. We tell the volume of the sphere is 4/3. Four pi r cube. I want the fractional error, which is delta v over v. We know from the rule that this is going to be equal to 3 times delta r over r. That's from the rule. Tell me if anybody disagree with that or want to see where that's from. You're good, yes, or
I
maybe.
agree.
So
Or,
yes, I said is I how it raised to, you're gonna put that before the delta
yeah,
r.
yeah. So we're getting 3 times, what was that r error? And this will give us your fractional error. All right. You can work that out and let me know what you get. And for your absolute error, you can work out what v is equal to, which is going to be 4/3. Same style again, 4/3. We keep in the pi, and we're doing, what was r? R was 15, right? Let me know.
Same question.
Yeah, we're doing 2v. So we worked out 2iv, and we said that it would be 3 times delta r over r based on the rule for fractional error. And it asks us for the absolute error. And as one of your students had correctly pointed out, seeing that you have delta v over v and you want just delta v alone, which is the absolute error, you would multiply both sides by v, and you would end up getting what I'm going to do right now. Just give me a second.
That's for the volume.
15 cube, I would assume.
All right, you mind starting over this one? The volume.
No problem. No problem. They gave us a volume formula, 4/3 pi r cube. And the fractional error. The fractional error is the absolute error over the actual volume, which is really delta v over v in this case. Now we know that from rule 3 with the propagation of errors that, let me go back over here. If we have delta y over y, the error would be n, which is the power, times the error divided by the actual value. In this case, or n is 3 because that is the power, delta r would be the error that they gave you, the 0.5, and r would be the actual 15. And that's how we get the 3 times 0.5 over 15. For your, which would be, I don't know if anybody had worked it out, which would be 0.1 based on my calculation. I could be wrong, but confirm that to anybody.
That answer.
And for V, we have 4/3 times. Remember, we're keeping the pi as is. So we're only using the 4/315 times 15 cubed. We're going to have 4,500 pi.
I don't hold it and 10,000 in cash. Was rejected by Germany.
And now to get delta V, which is the absolute error, we're going to do delta V is equal to, remember we're cross multiplying. So we're doing, we're multiplying both sides by V. Multiplying this side by V as well. This kill this. And so now we have 3 over R. Tell me if you can see the screen properly. And V, it should be equal to the 0.1 times 4,500. Which should be equal to 455.
Sir, could you mute the person whose mic is on?
Give me a second. Where specifically?
All right, don't worry. Delta V equal 3 pi. That's what V.
Delta V
R.
R. That's 3 delta R over R times V. So what we did was that we multiplied both sides by V right here. Or rework these to ensure that you have the correct values. All right. Let us see now.
So, all right, let me just understand.
Mhm.
To find the volume, right?
Yeah.
Find the volume. Work out the fractional error, work out the absolute error.
To find the volume, you use the formula them give. To find the fractional error, you use rule number 3, which is this that we have right here, so in the box. To find the absolute.
So the volume is 4,500 pi.
Yeah, no, you can always write the exact value after you write that, right? But we wanted to keep the exact value so that we can don't alter the value that we get in our final answer. So you could have very well written out 14,137.16694, right? But as I said, use up your calculator, and by now you should have a proper calculator in the process of getting one. The calculator should be able to have the exact pi value to use that. All right.
All right, so after find the volume, that's it then. Then you have the fractional
error. To find fractional error, which is IV, which we didn't get 0.1. And also the absolute error, which was V, and we got, probably I don't remember, 455. Now please bear in mind that these values are plus or minus. The fractional error and the absolute error are plus or minus values. Now that we're going to drop off the plus or minus.
Antonio.
Or zoom out the screen so we can set it up. Respect.
All right, what are the other question in tutorial one that you want to be worked?
We could look at number 5.
All right, no problem. So
I was going to say
we have, repeat,
4. Come on, continue.
we have P equal K times cube root. Oh boy. Anybody want to sponsor me a style? I'd gladly appreciate it. X y fifth root z cube. They want the percentage error in P, which is delta P over P times 100. Cool. Now, to do this, we have to go back to rule 2. So we're just going to put this here. So anybody can tell me what rule 2 is. Don't be afraid. They can text it in the chat if you don't want nobody hear your voice. Anybody at all?
Oh, you said when multiplying or dividing, we add the fractional errors.
Perfect. So they told you that K is a constant, so K doesn't have an error. So we don't have to worry about that, right? Now we know that X have an error, Y have an error, and Z is an error, and we know that we're all multiplying these. So we know that we're going to be adding up three things. We know that for sure. Before I move on, tell me if anybody disagree with me.
No, we agree.
All right, good. No, I don't know. I don't know how well everyone is in math, but you're doing engineering, so there will be a level of competency. So let me do a side note. If I have the square root of X, what's another way of writing that? Without using the square root.
X raised to the half.
And not perfect. Yeah, man. So enough worry then. All right, good. Everybody see that. Everybody know that, right? All right, better. If you don't know that, say something. Don't feel afraid. I can explain why. All right, good. So we have cube root X. So we simply know that this is really saying, just make a side note here. So we're knowing that this is saying X to the 1/3, right? Once more, just see the right. For this now, similar process. What we have for Z? What's another rare? Well, what's another way of writing this last term?
Z to the 3/5.
Awesome. If there's anybody that disagree, stop me, please. All right. So the now as the young lady said, other fractional errors. No, based on the question, they gave you the fractional errors already. If you notice, they're in percentage.
Hold on. So you said that what's the alternative method? So that's what, x to the 3?
X to the 1/3. My bad. The right is not that 100. I'm using a trackpad. The x to the 1/3. That's because we have root
And x to the 3/5.
z to the 6.
Z to the 3/5.
Yeah. You want me to write it over, or we can just visualize it?
Continue.
All right. No, they gave it the errors in percentage. That percentage is important. It simply means that they already gave it a fractional error for each quantity. All right. So let us work them out one as a matter of fact. I'm not even going to assume that everybody gets what's going on. So we know we have x to the 1/3. Using what we did from the volume and from the area, what is delta x over x? Anybody at using rule number 3, which was this. Zooming in on it for a little. Using what we know from this. Everybody seeing the y equal a to the n?
Yes.
Using what we know from y equal a to the n, what will we do for x to the 1/3 when we want to find the fractional error?
You would multiply it by 1/3.
Perfect. Perfect. All right, so I don't want to throw off anybody.
All right, I was saying it will be 1.
Let me use a different letter. What letter do we not have here? I don't want to throw off anybody. Let us call this b. X to the 1/3 is b, right? Delta b over b is equal to, don't get an exam go right, this equal b. This is just to demonstrate something to you. 1/3, which is the power, times the error that they gave you over the absolute value. But in this case, they gave you that portion of it, which would be 0.65. So not 0. Actually 0.6%, which would be 0.65. All right, let me keep another percent. The 110%. 0.65. I did not write it. They gave you the error already. They gave you the fractional error already. They did not give you it when it was raised to a third, but they gave it as x alone. 0.65, sorry. Tell me if anybody disagree with what I have or don't understand what I have. It's a different thing. This would have been 1/3 delta x over x. And they gave you this portion already. Cool. So all we're doing is 1/3 times 0.65. Everybody following? Or is there anyone that does not follow?
You can zoom out so we can see about the equation. All right.
All right, so we're going to step up the pace a little bit. So now that we understand what we're doing with this, we're going to do delta P over P in one go. I'm taking my time, but we're doing it in one go. Cool. So the power is 1/3. So we're doing 1/3 times. They gave me delta x over x already, 0.65. Add in the fractional errors. Sorry if it sounds like I'm shouting. Add in the fractional errors. So the next term would be y. Cool. They gave us y already. That would be 0.30. And the next term is z to the, what do we have? Z to the what? 0/5, right? So we're having 0/5 times 0.45. Work that out and tell me what you get, please. And did I lose anybody while working out delta P over P? So surprisingly, I'm not shocked that nobody not really replying other than a few people. It's something I do in class too. When teachers ask if I understand, it's fair. I understand.
Okay, I
so I'm going to ask.
I have a
repeat. Yeah, man. Tell me.
Right. So for Z, why is it that we did not multiply the 0.45 raised to 3/5? Is it because of the rule or there's another explanation for that?
Why we did not multiply the what?
All right, why is it that the 0.45 wasn't raised to the 3/5?
All right, so.
Do you understand what I'm asking?
it is not the error that is raised to the fifth, it's the actual value that is raised to the, it's not the, sorry, it is not the error that is raised to the 350, it's the actual value.
Okay.
So find the error, to find the error, to find the error when something is raised to the 350, we go back to rule 3, which is this over here. So don't ever go and raise the error to the 350. Or to any power. It's the value itself get raised to the power. Did I answer the question?
Yes. Yes.
All right. Anybody have a value for me yet?
Yeah, one question. But you use the 1/3.
0.786.
You hear me?
The question though. Yeah, man.
You hear me, Chief?
Yeah, tell me the question.
No, I'm saying where you use the 1/3, right?
Mm-hmm.
You use the 1/3 times the 0.65.
Yeah. Yeah.
Oh, no, because you had said to her a while ago that you're not using the 350.
All right. Let me go back to this B. This.
Yeah.
One. Right?
Yeah.
We'll call it x to the 1/3, all of that B. Cool. Now from rule number 3, we're always going back to rule number 3. In this case, I'm going to keep the two of them on the screen at the same time. Can you see the Y and can you see the B?
Yes.
Work with me now. Don't come off the line, you know. Delta B would be the same as what over the right and over the left hand side?
Delta V.
No man, over the where you have Y equal A to the N. You seen that?
It would be.
You seen Y equal A to the N on the left hand side, top left hand side?
Yes, yes.
Delta
Y,
B would be what?
Hold on. Y. Hold on, let's see. Y equal A to the N. Yes.
Delta B would be what over the right hand side? Delta B and delta Y is the same.
Delta B.
Delta B and delta Y is the same.
Okay.
That
Right,
sound like
right.
agree with me. That sound like
Yeah, man, you said delta Y over Y is the same as delta B over B.
Good.
Mm-hmm.
We have A to the N. You see the A to the N?
A to the N, right.
You see your X? On the right hand is the same as A. Cool.
The X would be the A in this case, because the A over here A is raised to the N, X is raised to 1/3.
So N would have been what then?
So N would be 1/3.
All right, perfect. Formula say N times delta A over delta A over A, right? Ignore
Right.
to the end of the delta A over A is what?
Delta A over A would be the plus or minus the error section over the. Hello?
Delta A over A is the fractional error in?
Yeah, the fractional error, right.
In what? In what?
The fractional error in A. No, fractional error in A, yes.
So, so we're multiplying the power times the fractional error in A, don't it?
Right.
Don't tell me right even though.
Oh, and they
make a move from go back over the other side of the screen. Tell me if you follow that.
And they give us the fractional error.
All right, don't jump it yet. Back to over here.
Okay.
Sir. They gave us the fractional error in X. That is why.
Which is X or X delta X over X represent the fractional error.
They gave us that. So we use the fractional error that they gave us and multiplied that by the power.
N. Yeah.
So you see where we have 3/5 times 0.45. They gave us the fractional power in Z. They never give us the fractional power in Z to the 3/5, you know. They gave us the fractional power in what? Z. So to find Z to the 3/5, the fractional error in Z to the 3/5, we have to multiply 3/5 times the fractional error in Z. So when in doubt, try to match what power equation that they give you to the y equal a to the n. If you write out a to the n and write down the second formula directly under it, but map it. Map what is delta y, map what is n, and map what is delta a. Map what is y and map what is a. You can't go wrong.
All right, peace.
Anybody lost or still have any questions I can answer? I have no problem answering. All right, no problem. So silence means consent, as Dr. Isaac would say.
Hold on.
Question.
So why would
Where you at the top, right? Where you have x equal 1/3. X to the power 1/3, right?
You wanna say B?
Yeah, man, I know why I did that, but yeah.
Tell me.
What may I say is that sorry about the noise, I'm at work. Is it a regular, is it a formula or just a way how to make it easier?
If what is a formula? If x to the 1/3 equal b.
Yeah, how you change all that to a fraction and then times by the percentage error.
Over there have the rule. Over there have the rule for things with a power.
So that's how you would do it.
All right, wait. All right. Let me answer two things and hopefully one of them answer your question. You see where I have x to the 1/3 arrow b, I just call that b to just try to map it to the y equal a to the n.
No, I understand that, you know.
All right. How we get the error to be n times delta a over a, like how they figure out that is the error?
No, man, I know that was the error, man. That's what they gave us.
So how did you switch from the square root
to
then
how did I move
have
from
the square root? Right.
All right, so
if it's how it should be worked, or if it's a formula to work, it's hard.
All right, the reason why we remove the square root sign is because our formula never give us in the square root sign with the square root sign. Our formula or our rule gave us in the power form, which is raised to some power, right? You get that?
Yeah, man.
So in order for us to work it, we put it in the power form. Now, it is highly, as a matter of fact, probably in your exam, I do not necessarily expect you to go right to z to the 3/5. Not saying that you can't do it, but I want you to be on the lesson to look on it and know. Following me? So you don't have to write out, you don't have to transform that to the power form, but you just know mentally that the power that we're working with, the n value would be 3/5 for the point. All right. I think we got an answer for P. Somebody had given it, but you know more than capable by calculating that. What the next? Do you know one more from? All right, wait. Before I say that, how much more from this you want us to do? All right, let me ask this a different way then. What's the other question you want me to work on this tutorial sheet?
I know that's what I meant, man. We can do 2 more, I guess.
Or we're good now?
No, I would like for as a person stated, 2 more, because this for me also is an issue. So maybe we could do 2 more as was stated.
Can try.
All right.
Wait, 7 look kind of too easy.
7.
Yeah, I'm gonna try 7.
All right.
And probably the 10.
So 7 and 10. Anybody disagree
I
or
don't
agree?
want to make all the suggestions, so let me just go with 7 and somebody else can choose an
What the other number?
Maybe you, Antonio, could look at one that is difficult and
All of them
probably you could
difficult.
well, I agree.
If you are said that.
No, because I haven't done this in years now. So rusty. We're going to do
that. They are real big. Yeah, man.
give me a second. Man.
By 11 o'clock.
Now we can do 11 too.
Alright, this was extra 56 times and fine. That just give me a second. Just looking on something for. So number what again? The one with the table number what? Anybody?
I'll try 7.
Number 11.
One question is,
yeah.
Just looking back on something on number 5. When we use we got the percentage error.
Yeah.
But the the delta A over A gives us the
Beautiful question. Continue.
gives us the delta A over A
Does not give you the percentage
gives
error.
us
It
the
gives you the
fractional error.
fractional error.
Yeah, but in the calculation we use the percentage error as the fractional error.
I want to see how that makes sense, don't it?
Yes.
What kind of madness am I doing? Right?
I use this on a Mr. Madness.
But come make it work with each other now. I'll go back to delta y over y, cool?
Yeah.
I multiply this, the right hand side by 100. What does I do? What am I now? What do I now get? Don't overthink it.
No man, come
But
again.
most of delta y over y equal that little mess right there.
Delta y
No,
over yes.
if we multiply what we have on the right hand side by 100, what are we forming?
The percentage.
No, that's all I can guess.
Yeah, man, I guess.
To multiply something by 100, do I get the percentage? Well, they divide it by 100. They get the percentage. No. It's a percentage error, simply a fractional error to the 100. All right. I don't know rocket science. So the question asked specifically for percentage error. So they already gave me the errors in percentages. So I use them as is. The one I could have easily said 0.65 over 100, 0.30 over 100, 0.45 over 100, but that would have given me the fractional error and it would have been quite small. So the percentage.
Yeah, it's after NP. I just saw it.
Number 7 was the other question, right, team? Yeah, man. Number 7 was the other question, right?
Yes, Santo.
All right. All right. That's the percentage error indeed. Give me a second, please. All right. Sorry about that. All right. What can I get for this? Oh, I did not explain this. All right. So percentage error, we're doing the similar thing. We're working on the fractional error and multiplying that by 100. Tell me what you got for the answer. Hello?
Working it out, just a minute.
41.15.
Which question is it?
Number 7, I think.
7.
Morning, sir.
Yes.
Somebody just gave an answer.
41.15%.
Come again.
0.04%.
0.04. Well, why are that for the other number? I don't know what they're not
0.00411. And times
so
that
0.005
over
over 1.215. You're getting.
You get 0.412.
But not that number then though.
Oh, all right.
But I get 0. Well, you're right. You're right.
Yeah, 0.412. We're just rolling off what this.
You want, for physics, you want to go up to the highest decimal place that they go up to. So they give it accurate to 3dp, give them back accurate to 3dp.
All right.
For general, this is now general purposes. Keep it as exact as possible. Where possible, store it in a calculator. Where are we now? All right, so everybody understand 7i?
Yeah.
7i are the troublemaker.
Yeah.
So tell me if everybody understand I. All right, so no, let me see if anybody is saying anything. Alicia or Alicia.
Alcian. Alcian.
Alicia. You're correct. Ish. Don't throw up your numbers. Round correctly, cool. 0.4115. You know, 5 or more, you round to the nearest whole number upwards. So we're gonna do some little teaching now.
Before you proceed, zoom back out from there, please, so we can see the initial question.
Not even initial question right down in the first place. All right. I'm going to get it on the screen.
So this is not 20. Oh boy.
Move on now. The T.
Yeah, man, you can go on now.
All right, so we're going to do a little lecture. To work out this, so when they give us multiple values like this, have to do a little bit more stuff. We have to find that error on our own, right? And the first thing you want to do is to find the average. So the average is going to be, honestly, I'm not gonna write out all these numbers, so just work with me. 496 plus 497 plus 503 plus 496 again plus 501 divided by what? 1, 2, 3, 4, 5. I'm pretty sure everybody understand that, but tell me if you miss me. Tell me if I've lost you. All right, let me ask a different way. Since somebody no answer, tell me if you understand. Oh, I'm gonna get the average.
Oh, average. When you add up everything and divide it by amount of numbers of the day.
Yeah, man.
Awesome. So when I go for it down that, I'm pretty sure I said everybody should be on that level already. All right. Now to find the error, computer freezing, can't manage this. All right. To find the error, we're going to each element, and in this scenario, element is a 496, 497, 503, 496, and 501. We're doing each element minus the average. Everybody following me?
Yeah, man, go on.
By the way, this is modulus. We do the modulus of it, all right? What about this? Everybody know what modulus mean, right?
Yeah.
What was the other number? Can you tell me the second number? If I have the wrong number written down, just let me know. Okay. How much more numbers I have left? Right. Where are we? 503, 46 again. And then the other one is function one. You can see this in my screen, everyone.
Yes.
All right. Oh, let me just check if these values are correct. All right, awesome.
So shouldn't the second one be 498?
The question gave me 497.
Instead of 97? 497, 498.
It's 498. Everybody have for number 7?
I have 497.
And it's a different paper I'm working from.
The paper I got a 497, but in any instance you can put 498. Just that you'll get a different answer from us, but the principle remains the same, right? Tell me the answer for the second, third, all these.
First one is 2.6.
Really?
1.6.
1.6?
Yeah.
Brilliant. Come again.
4.
Work out already, don't it? From before class.
No, just worked out all of them.
0.4.
2.6
Next.
again.
4. Wait. Which one is 4.65?
No, 2.6 again for the 496.
Oh, just want to make sure. All right. On the 501.
2.4.
All right. Now the next step.
No, 2.4, not 4.
Last one, the answer is what?
2.4.
2.4.
So wait there. All right. Everybody confirm this. The next step. Yeah, tell me.
Yeah, we confirm them.
Oh,
They're good.
all right. So the next step is to average all of these. All right. So you're doing all these divided by 5. Once more, I'm not going to write that.
I got 2.72.
You're completely correct.
So some of these are not negative.
Modulus, so doing the modulus.
Oh, okay.
Yeah, this sign don't really matter right now.
Reason being is that the error is going to be plus or minus. So it can swing in either direction. All right, now the answer for the percentage error in T. Now, we as geniuses know, we definitely know that we have delta T and we have T. I think we worked out T. So we can find II, right? So 498.6. All right, but it's equal to some number. Moving too fast. Everybody understand the delta T over T? Somebody something in the chat.
I remember where I get the delta T again, and I will get that one.
Get the delta T. Add up all the errors, 2.6, 1.6, 4.4, 2.6, and 2.4. Divide them by 1, 2, 3, 4, 5. All right. Where are we now? Value of G. This requires me to know how to calculate gravity. Let's see. All right, so I'm gonna give a minor disclaimer here. This may or may not be right, but we're gonna try it. All right.
For the other one,
I did not record the answer. What did you get?
or is it 5.45? I'm trying it again.
You should get wait, did they ask for the percentage error or the
Percentage error.
0.54 546%.
You can fix that calculator.
And then whatever to this formula before S equal U plus half H E squared.
Yes, sir.
All right, my calculator show powers. You take it off of that. No answer the powers. My calculator show the power. No answer the powers. Want the whole thing in decimal.
The calculator is showing you powers.
Yeah, that shouldn't is to the power of 3-3.
Yeah, man. So, you know, multiply those. Yeah, make the calculator rule, I know. All right. Number 7. It said that the ball accelerated due to gravity and started from rest and went a distance of d. Therefore, u is initial velocity. So we know say s equal. We know that initial velocity is 0 plus half gravity is the acceleration we're using, t squared. Where s is distance by the right. So we have d equal half gt squared. Oh, find g, right? So we know that this is 2d divided by t squared. Tell me if I lost anybody.
You're good, man.
Yeah, man. Go back over.
Oh.
Yeah.
All right, so we're using the formula ST2T plus half AT squared. Why are we using that? Because that formula have a distance, initial velocity, and acceleration, which are values that they gave us. I cannot say that there aren't other formulas you could use that is possibly so, but we'll use this one, all right? Now, we know that U is initial velocity, and it told us it was at rest, so the initial velocity would be 0. The acceleration is due to gravity, not because somebody pushed it. This was due because of force of gravity, so we're using G instead of A. So setting U to 0, that term becomes 0, so we're only left with, remember, motion formula. This is D. So we end up with D equal half GT squared, right? And I just wrote that over right here. It asks us to find the value of G. So all I did was transpose G. To do that, I multiplied both sides by 2 divided by T squared. Now, this was a bit intentional. Well, I wouldn't say we, but there comes a time when you need to transpose things like that. Sooner you grasp that, the better it is for you. Because nobody not going to mark you for this when you reach second and third year. They're going to just expect you to just do this. Right? So, anybody question how I get 2D over T squared? No, no.
No man, you
All right.
understand.
All right, no problems. They give us, no, they never give us. We figure what T was, and we know what D was. So 2 times 1 point. Oh, by the way, I want to know, say, T in milliseconds here. All right, don't make a mistake. When you have,
So
let me
like, we're supposed to write the units.
Yeah, let me tell you the correct thing to do. Always use SI units, base units. That's the correct thing I'm to tell you. Now, if all their units are in milli or micro or kilo or whatever the case is, then it may not necessarily be required of you to convert it to base units. When in doubt, go to the base units, all right? You can't go wrong. The average time was 498.6. No, milli is times 10 to the negative 3. And we're doing this all squared. Don't play here and try this in your head. Put this in the calculator. 2 times 1.215 over 498.6 times 10 to the negative. I'm assuming that everybody knows how to put this in their calculator, right? 9.774, which is something close to what we had expected. That's 775 actually. Don't forget the units here. Meters per second. Tell me if I lost anybody. Are we following?
Yeah.
All right. The one you absolute error in G, no, it gets tricky. We're gonna write back that G formula. Two G equal 2 times D over T squared. Now, let's see what people left. 30 people in learn how to do this. Hope other sit down here can figure it out. Open question. Who can tell me how I'm going to find the fractional error in G?
Actually, the question.
You tell me so somebody just started. Anybody can pitch in and continue. Tell me. Don't be shy.
Delta D upon D.
Boss a talk, all right. Next.
Plus 2 delta G over G. T plus
Oh,
plus 2 T delta T over T, sorry.
Oh. That's it.
Going to multiply both sides by G.
4. Why?
In order to get delta G.
Perfect.
So
And if ever-
question now, we're supposed to ignore the 2 that's multiplying D in the original equation.
Love that question. The 2 is an absolute value. So it does not have an error. Understand?
Okay.
Okay, then I sound convincing neither, but
No, because like I understand when you say it just no, but then in my tutorial class now we had a question and then my teacher and multiply it. But then I never
well,
really see that like in the lecture, but in terms of that in the tutorial, and then now you say something different. So I don't know what one, but okay.
Well, let me answer this now. Consult with your lecturer or teacher as it relates to whether or not you are to multiply by the 2.
Repeat, please.
Consult with your teacher whether or not you're to do an additional multiplication by 2.
Okay.
All right. But for this thing, we generally just keep things that have errors. If you notice from number 5, it told us K is a constant which is assumed not to have an error. So because of that, because it does not have an error, it cannot be, we don't factor it into the error equation. Similarly, for when we were doing the area, we had 4 pi. 4 pi was an absolute value and we never factor that into the error. But your lecturer supersedes whatever I say, so consult with him after this. All right. But separately from that, is it that you don't understand anything that we've done today?
No, I understand. But it was just up to that point now because I remembered when he gave me that question in the tutorial class.
Okay, so we're using this 2 right here, which is from the power of the t squared, but in this example, we're not multiplying it by this 2 that's up here in the numerator. So somebody tell me what we have for delta over the we did calculate it already. Did we?
0.147.
Did we calculate delta D over D already?
0.147 need the particular square.
0.147. Sure.
Try it again.
I think delta D was 0.4 something. I remember some people were eating up the numbers. See it up here to 0.412. Remember, it is the error over the actual value. Did somebody work out the delta T over T value? 2.72 over 17.6.
Just say that 0.004.
For what? Delta D over D?
Exactly that, delta D. D over D.
You're doing 0.005 over 1.215.
Yeah.
Use your brackets.
I'm gonna get 0.004. And that's some program on my calculator. Try this again. 0.004.
So this is the formula for delta G. 0.412 plus 2 times 5.455 times 10 to the negative 3, and everything times the gravity 9.775. Everybody following that? No, it's late, but
No, I'm not follow that.
all right. Tell me which one you losing.
So I'm gonna get 0.412 and the value for T.
All right. Boop. Work with my open bracket. Clear what up in your calculator. Work with my open bracket.
Mm-hmm.
0.005 close bracket. That divide sign open bracket. You have that?
Yeah, that would tell us I get 0.004.
So me I do something wrong there. You're right. Sorry. You are completely right. This was the percentage error. This 0.412 was the percentage error. Make those changes, please, everybody. The question had asked for the percentage error in D. Similarly for T.
I'm just want to sure something I get off in it because I was like, what if my calculator wrong?
Oh man.
Because I spend the whole time I try to change every mode on it to try to get the answer.
This value is this is the actual absolute error right here. So we'll do this. So with the delta d over d plus delta plus 2 delta t over t all times the gravity value. Whatever you get for that will give you your absolute error. No, it's a bit late, but this one is completely up to you. Do you want me to work one question from the night?
So when I next time this artist?
Not anytime soon. Probably another person.
Okay.
Probably another person be doing it. Let me know if you want me to work another question from the tutorial to a question from tutorial 2.
A question from tutorial 2. I have no question.
One with our
Hold on there.
Miss Bennett, Mr. Chin, Mr. Clark, Mr. Ferguson, Miss Miller, Heyman, Mr. Dennis, White, Mitchell, Clark, and everybody else. Choose a question from tutorial 2 and send it in the chat, please.
So I work one question. All right.
I may work too. May work too.
Go to 5.
Yeah, man, just send it in the chat. Everybody send a question in the chat. 7, 3, and alright, so we don't have a homework question. Mitchell said number 4. All right, no problem. We have 25 people here, people going, so I'm going to not rush because I do want you to understand what we're doing. All right. Disclaimer again, I'm a bit rusty, so just say it, please. If you see me making a mistake anywhere, just say something, and where possible, just verify with your lecturer afterwards. All right, so Joel Mitchell we're doing that. All right, so let's say at t equals 0, a equal we're at plus 3j. Now, from class, you should know by now that dx by dt, somebody answer quick, what are equal? What is the name of that? Dx by dt?
Acceleration.
No, sir, that's right. Come again.
Differential.
Differential.
Nope.
Is not the rate at rate of change.
Nope. Yup. I mean, everybody was right. It is a differential. It is the rate of change. But I'm looking for velocity, all right? Somebody tell me this quick.
Second differential.
Yeah, we're going there.
Acceleration.
Awesome. Somebody tell me what this equal to.
Acceleration.
All right. Perfect. So, with that being said, if dv by dt equal a, what is v equal to? Fine, true, but how do I find the velocity?
Which question is this?
Number 4, but the question no matter. This is the general principle. If dv by dt equal a, how do we find the velocity?
We integrate.
You would integrate the acceleration.
Why? Why we cannot differentiate again? Anybody have any answer to that? Or because your teacher say you must integrate, that's why you
Sir.
integrate?
Sir,
Yeah,
sir,
I'm hearing you. Tell me.
it's not working.
Repeat. Repeat.
Sir, what was the question?
The question that I'm working right now.
No, the question you asked.
Oh, I asked why we integrate. Why we put a differentiate again or do something else.
I'm glad you explained it because honestly, I don't know.
All right, good. A lot of us are integrate because teachers integrate. But make attempt to try and just go through why we integrating. So what's the, well, we know for sure that the opposite of differentiating is integrating. You know, differentiating is finding the gradient. You might never know that. That's what differentiating is. It's finding the gradient at that point. But yeah, integrating find the area. So we know that the opposite of differentiating is integrating. Fine. What if we were to do this? What this read say? Or say this in words. Anybody, just say this in words.
integrate dv, the integral of
Integral of
dv.
change of velocity is equal to the integral of acceleration times the change in time.
All right. So I could have also said this. Would have given us exactly the same thing. Reason being is that the dt here would cancel. What this is saying is that we know that integral is the opposite of differential. So if we're integrating a differential, we're going to get back the same thing that we had. Without getting into a graph or an area or a gradient or integral is a differential. Yeah. Integral is the opposite of differential. So if we integrate in a differential, we're going to get back what we started with. It's, for example, saying that we find the square root of a squared value. What is the square root of 5 squared? What is square root of 5 squared?
5.
They're each other, don't it? So this is exactly what happens. This and this is exactly what happens. And when we integrate a differential, we're going to get our original value, which is v. And so we now end up with v equal the integral of a dt. Integral a with respect to t. Now, I'm sorry if my explanation is not as elaborate as you might would have wanted it to be. However, they expect you to move from this step to this. And you're supposed to just know that this and this happen.
Antonio,
Yeah, tell me.
all right, let me get this straight just by your definition and equation you show. So just as how integration is basically the opposite of differential, right? The reason why, in my opinion, the reason why I integrated was because they actually want to find the values of v and t.
You want to find the value of v by itself, not dv, not dt, but v. And to get v by itself, I have to remove the differential. And the only way to remove the differential is to do the opposite of the differential, which is to integrate.
Boom, see you have an integral sign over the right-hand side as well.
Yeah. Remember from 6th grade, anything we do to one side, my friend?
Do to the next one, respectively.
That answer your question?
Yeah.
All right. So even though we're no longer using maybe the letter or say, but it's the symbol still works. If I differentiate one side, I have to differentiate the other side. Equation of a balance. All right. Now all of that was maybe good for you, maybe it wasn't good for you, but we're gonna start with the question yet. But I did this just in case you don't get to work any other question. You have a groundwork to start with. So again, just the one more thing for you. How would I find x given dx by dt equal v? What would x be equal to? All right, let me see what we make here from here. Katie and Mason. Katie and Mason. Henry Henry. But they want to give it a try?
Sure. Hold on.
Go ahead. Go ahead.
X.
Yeah.
Is it the integral of v dt?
Perfect. Now, we now guess again. Look on it. We want to get x by itself. So we're going to send up the dt. So we have v dt. We want to remove the differential. So we're doing the opposite of that, which is integrating. But anything we do to one side, we have to do to the other side. So we now get x equal to integral of v dt. All right?
X is what? Displacement.
My apologies. X is displacement, T is time, V is velocity, and A is acceleration. All right. Now the question asked to determine.
So displacement is the integral of velocity then.
Yeah. Well,
Right?
yeah, but you don't usually refer to it like that. Reason being, you're usually given the displacement, but in the scenario they actually calculate it use. All right. All right. So they give me the acceleration. They want you to find the x and y components of the velocity. So how you're going to do it is, as we had said, we're integrating the acceleration function. So we're going to say now, v is equal to the integral of 4i 3j. Right? Tell me if I lost anybody. Did I lose anybody? Late night, night, more answers. Yes, no, anybody?
No, sir.
No.
No, you don't understand. I know you understand.
We're good.
All right. No, the integral of 4 is what? Talk to me, anybody.
What do you mean the integral of 4?
The integral
As in
of
4i? Oh,
no,
the
the
integral of 4 squared.
4i t.
The integral of 4 with respect to t.
40.
40.
40.
Don't go in on the exam and write I squared divided by nothing or I squared. Please. Please. I beg and plead. I and J are what? They to differentiate the X, Y, and Z components. If you did have K. Cool. So don't go square in an I. Don't go think I and square root of -1. Don't any other. I is just the X component, J is the Y component. Cool?
Yeah.
Integral of 3.
3t.
Right back the J and the I. This is your velocity function now. Cool? You know your units are meters per second. Hurry back to the units, please. Always. No, this probably should be doing what I'm saying, but as I say, writing and this is not the most efficient thing. All right, good. Tell me, everybody, I see some messages here. All right, you're welcome. Corner, I think Corner is gone. If you have to leave, you can leave. Who want to stay can stay. I'll be going up until 12 or until you have 0 participants.
Up until when?
Drop asleep or 12 o'clock or 0 participants, whichever one comes first.
Wait, until I'm still.
Speed of the particle. Speed of the particle. Now, who wants to tell me how we find speed from velocity?
Speed is the magnitude of the velocity.
Perfect. So that would be the square root of
4t squared plus 3t squared.
by the way, it is not 4t squared, t all squared. May I talk from experience? I've made these mistakes, all right? So, you know, exam pressure, test pressure, you make some silly mistakes. It's not, so it's not 4t squared, it's 4t all squared. Your answer in 3, 4, 5 triangle, right? Anybody know what the hell we just said? What 3, 4, 5?
Yeah, like the three sides of the triangle.
Yeah. So I know so this is gonna be 5t squared. But I mean and I can work it out. 4 squared is 16, 3 squared is 9. Yeah, that give us 5. It's good to know these things, right? This is some stuff and you just move on. Just because it's speed, it doesn't mean your unit what change. All right, B. If I'm moving too fast, no person with ask the question is still here. Oh, plus 50, plus 15. J.
You say speeds are 125?
Yeah, 125. Displacement, no. Who can tell me how? I'm not even even ask her because I go through this, but how we find the
Use the
displacement?
integral of V.
All right. So I know it's all over the place, but just stay with me. So our V function is here, right? So we're integrating this. So we have the integral of 4t I plus 3t, right? 3tj. We integrate um, so we know we're getting 4t squared over 2 plus 3t squared over 2. Tell me if anybody disagree with me.
I agree.
No, we know that 4 over 2 is the same as 2. Don't drop an I. I'm saying it because I'm doing it. Sorry about that. Don't drop the I and don't drop the J. 4 over 2 is 2t squared I plus what is a 5 second? All right. So this is equal to 50 I plus So this is 37.
0.5.
You could have also used S equal UT plus half AT squared formula. However, based on the question, I wanted you to know that you're supposed to integrate again. All right. Da, 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 da.
But would it be more be like them want to use S equal UT plus half AT squared? Because in the question, them tell you say them want tell you like them want hidden the initial value.
Personally, as I said, you can use either way. However, seeing that you would have already have the velocity, you would have already after the work out the velocity would have been a simple integration and then substitution. So whichever one you think gives you the answer, the quickest I use that. I would have draw for the integration. You get me? But if you think that using the half AT squared is simpler, then you can do that. Where are we now? All right, so Roshan is here, so I think you're the lucky person. Roshan answer number 2. Roshan answer number 2. Number 2 says initial velocity is that 0 and that goes that with an angle. Roshan draw for the hardest question. Oh, this is a little direction of the axis. All right. But you can see my screen still.
Yeah, we can see.
You know which axis is X and Y. You would have to know that before I can reach a U-tech. 125 degrees from the X positive X would me. Agree or disagree?
125.
Yeah.
Oh, I think that wouldn't that be more than 180?
It would actually. From the other way around, sorry. From the other way around. Would be here. Somewhere around here. So I have my 125. And because I have 125 here, the line that would be brought up so would be 50. So I get that 180 minus 127. Which is the angle on the straight line. Equal 55. So now working with this triangle.
All right, so I have a question. So the first thing we're trying to accomplish is what? To split the acceleration.
Yeah, you want to split the acceleration into its x and y components. Then you want to put the velocity into its x and y components as well.
So in order to split the acceleration, we're going to use cos and sine, right?
Yeah, your x is going to be on a cos and your y is going to be on a sine. So this is your x. This is your y. So we're going to have ax equal
So is it going to be cos inverse or no?
how the angle already use cos inverse and also an angle. I'm not.
So is 40 cos 55?
Four cos 55. But I think it would be minus based on how this is. I think it would be minus. I don't want to give it a wrong answer, so I'm going to pass on this. However, the steps should be to use magnitude times the use the magnitude times the cos of the angle in the x direction, the magnitude and the sine of the angle to get the y vector, and that together would have given you your a. Then you use that to get your velocity in x direction and velocity in the y direction, and you substitute the value of t in that both. I would have to, I don't want to give it incorrect answer for this. I'm not quite sure of how to work this out. So I have to pass on that. But it's now 11:58, so that would be it for today's session. I'm not sure what the plans to keep a second session with another person, but he'll let you know. So thank you for coming, everyone. I hope that I was able to assist you or to make stuff clearer for you. All right. Audience and Darby.
Thank you.
Yeah, man.
Hooked up my G.
Yes, sir.
Respect.
Yeah, man, thanks.
Good night to all. Thanks for coming out. I hope we really do assist you in your first test, and I hope we can get a lot of A's from this session. Hopefully you can hear me.
Yeah, I think they can hear you. And everyone who don't know who was speaking a while ago, that's Darby, SOE president. So, night Swavy and night Darby.
All right,
Have
Mr.
to
Thanks.
meet tomorrow morning. Everyone.
Thanks for your time as well.
Definitely.